Hello student. Today we are going to a second lecture on the solid state physics chapter number 3. So today's point is the coercive energy and in the formations of solids. So what is the question now this? Give the importance of coercive energy in the formations of solid. A crystal structure will be stable if it is a total energy lower than the energy. Okay, when atoms or molecules are free, okay, when the when the atoms or molecules are free, that is the coercive energy, which is the difference between the free electron configurations, thus out of the or thus out to the positive, out of the positive. Okay. किंवा configuration पर्यंत लिहायचा the coercive energy which is the difference between the free electron configurations. Next, ionic bond. So ionic bond, the ionic crystals are formed due to electrostatic column, so alternative force between the positive ions and negative ions. The ionic bond result for the electrostatic formation interactions, right? बघा परत the ionic bond result for the electrostatic interactions of positively charged ions, isn't it? When oppositely charged ions binds together under the influence of electrostatic attraction, it is called the ionic bond. That is example sodium chloride, calcium chloride, potassium chloride, etc. Isn't it? So आता कॅरेक्टरायझेशन काय आहे त्या कॅरेक्टरायझिस्टिक्स काय आहेत तर याच्या अशा कॅरेक्टरायझिस्टिक आहेत आयनिक बॉन्ड्स आर स्ट्रॉंग आयनिक बॉन्ड काय असतात स्ट्रॉंग असतात दुसरं इट हॅज अ स्ट्रॉंग बॉन्डिंग therefore it has a melting point and boiling point. Third, ionic bond crystal structures valence electron is also perfectly bonded with with ions. Therefore, ionic crystals are insulator in like number of free electrons, isn't it? Ionic crystals generally form closed or packed structure. Fifth, normally ions crystals are transparent to visible light. Okay, they are quite soluble in ionizing solvent. Huh? Such as water, the solutions being highly dissociated with the free ions. आता हा नवीन पॉइंट आहे बघा मेडलग एनर्जी मेडलग एनर्जी और इलेक्ट्रोस्टैटिक एनर्जी so first this downward side so मेल्डग एनर्जी और इलेक्ट्रोस्टैटिक एनर्जी म्हणजेच काय the main contributions the main contribution to the binding energy of ionic crystals is electrostatic types. Okay, is a call as a molding energy. हे दोन मार्काला डेफिनेशन विचारतात. The most common crystal structure from ionic crystal is sodium chloride as follows. So modeling constant for sodium chloride is denoted by alpha. Let UIG be the interactions energy between ions are I and J. We define a sum UI which includes all interactions between ions I and all other ions at the crystal is ui is equal to j summation u I j. This is equation number 1. So the interaction term uij may be written as the sum ui of two terms. One, column interaction energy like plus or minus q square upon gamma ij, where gamma ij is distance between ions I and j, ions and j. Second, central field res- repulsive potential is lambda exponential minus gamma gamma ij divided by rho. So where lambda and rho are uh, em- empirical parameter, empirical parameters. Thus, total energy of interaction between two ions I and J becomes Uij is equal to lambda expansion minus gamma gamma ij divided by rho plus or minus q square upon gamma ij. This is equation number 2, where positive sign is indicate for the like charges and negative sign taken is unlike charges. The repulsive terms describe as each ions re- regest, regest overlap with the electron distributions of neighboring ions. In sodium chloride structure, the value of Ui does not depend whether the reference ions I is a positive or negative ions, as long as it is not near the surface. The total lattice energy is denoted by UTOL, means the total lattice energy of crystals composed of n molecules or 2n ions, as U total lattice energy is equal to NUI. This is equation number 3. The total lattice energy is the energy required to separate the crystal into indivisible ions, uh, ions. For the convenience, we introduce quantity of Pij such that gamma gamma ij is equal to Pij into R. This is equation number 4, where Pij is a dimensionless quantity. Okay? Pij is a dimensionless quantity and R is the ionic separation in a crystal. Okay. Thus, we spill the interactions between the ionth term or jnth term ions as Uij in a bracket lambda expansion minus r upon rho into minus q square upon r square. This is the nearest neighbor, and plus or minus 1 upon Pij minus q square upon r is a other constant neighboring otherwise. This is equation number 6. So thus UTOL energy म्हणजे काय total energy lattice is equal to NUI. This is N J summation Uij is equal to N in a bracket Z into E expansion minus R upon rho minus alpha Q square upon R, and Ui is equal to into Z into exponential minus R upon rho minus alpha Q square upon R. This is equation number 6, where Z is the nearest neighboring of anions and alpha is equal to plus or minus upon Pij. the molding constant. The molding, molded constants. This is equation number 7. The sum of should include alpha nearest neighboring contribution, which is given by Z at the equilibrium separations. So D total energy lattice energy D UTOL divided by dr is equal to 0 and म्हणजे total energy काय आहे कॉन्स्टन्स आहे from equation 6 we have then dui upon dr differentiate is equal to z lambda upon rho and exponential minus r upon rho plus alpha alpha a square no, q square upon r square is equal to 0. This equation number 8. At the r is equal to r0, the equilibrium nearest neighbor separations. Now, z z lambda uh, x divided by rho exponential minus r upon rho is equal to alpha q square upon r square 0 then r square ro square ro square into expansion minus ro divided by rho is equal to rho into alpha q square upon z alpha z lambda. So ro square expansion minus ro divided by rho is equal to rho into alpha q square divided by z lambda. This determination determines the equilibrium separation Rho if the parameters rho and lambda are known. जेव्हा ते आपल्याला known असतील तेव्हा expansion minus r o divided by r capital R is equal to p is equal to exponential is equal to minus ro divided by r is equal to alpha q square upon ro square into rho into z lambda. This is equation number 7. 8. This is a 9. This is equation number 9. Put this in equation 6. Put this put this value in equation 6, then we get the total lattice energy at the equilibrium separations R R O separation O may be written using the equations 6 and 9. Okay. Total energy, U total energy N into alpha E into Q square divided by R0 square minus alpha Q square upon R0 and R0 Q square आपण कॉमन काढू मग आणि बघा रिअरेंजिंग द टर्म रिअरेंजिंग करण्यासाठी काय काढू आपण काय करू अल्फा क्यू स्क्वेअर अपॉन आर स्क्वेअर हे कॉमन काढलं तर मग काय मिळेल 1 मायनस रो अपॉन आर झिरो ओके बाजूला काढलं 1 अपॉन आर झिरो so this equation number 10 at the equilibrium the term n alpha q square is a melding molding energy. So that is uh, U is the molding energy is equal to minus n alpha q square upon r0 and the total energy of the molding energy 1 minus rho upon r0. Note that total energy has to be negative for stable so stability since when the separated the ions have an energy of interactions for the suitable sub, sub, stability total energy being the less than this and the fact that rho upon r0 is the very small so that the melting Middle energy contributes very large to the cohesive energy. आता evaluations of the Melding constant, Melding constants denoted by alpha. The question कसा विचारता? Show that Melding constants for one-dimensional arrow of ions to alternate the sign is 2 logs 2. Okay. So let alpha is equal to summation of plus p upon plus upon pi if we take the reference ions as negative charge, the positive sign will be used for positive ions, negative sign for negative ions. Consider linear changes of one-dimensional lattice shown in a figure. Let R be the interionic spacing. Interionic spacing since Pij is equal to gamma ij upon r. We have we have Pij is equal to 1, 2, 3, 4, 5, etc. Like uh, alpha upon r is equal to 2 in a bracket 1 upon r minus 1 upon into 1 upon 2r plus 1 upon 3r 1 upon 4r plus dot dot like this. So this is minus आहे त्याच्यामध्ये 1 upon r minus 1 upon 2r plus 1 upon 3r minus 1 upon 4r like this dot dot. Alpha is equal to 2 r2. Okay. 1 कॉमन काढला आहे तो आर म्हणून हा आर कॅन्सल झालेला आहे. 1 1 अपॉन 2 हे सगळे आर आर कॅन्सल झाले त्याचं फक्त समेशन राहिलं. दिस इक्वेशन नंबर 1 मायनस प्लस लिहिलं रेफरन्स. ओके रेफरन्शियल. नाव 1D lattice of oppositely charged ions, the factor 2 occurs because their weight and on the left each distance is rj is equal to nr. So with some with some this series by expansion like in log in in a bracket 1 plus x is equal to x minus x square upon 2 plus x cube upon 3 minus x 4 to the power 4 upon 4 plus like this. Okay, this we put x is equal to 1, then we get 1 plus x 1 घेतला म्हणून 1 1 झाला तो. आता इन लॉग आता हा 1 म्हणजे 2. ओके and is equal to 1 and 1 upon half square plus 1 upon 3 चा square like this. Okay, then log 2 हे 2 झाले म्हणून alpha upon 2 from equation number 1. Then alpha 2 log into 2 is equal to 2 into 2.303 into 0.301 naught. This is equal to त्याचं मल्टिप्लिकेशन करून आपल्याला असं मिळेल अल्फा इज इक्वल टू 1.3861 like this. Okay. आता for the 3D structure Medlog constants alpha sodium chloride 3D structure. The series is not conversions. Thus, for sodium chloride structure, taking chlorine ions as central reference ions, we have for nearest sodium ions at the phase center P is equal to 1, then 12 chlorine ions for which P is equal to root of 2. Since these are nearest next nearest neighboring in sodium plus ions at the corner given by P is equal to root of 3. Again, again the 6 chlorine ions at the center of 6 different unit cells such that 6 phases of reference and those of 6 unit cell. This contributes to the middle Medlock constants as Medlock Medlock constants as alpha is equal to 6 upon 1 minus 12 upon root 2 plus 8 upon root 3 minus 6 upon root 4 like this. Now आपण जर याला घेतलं यांना सोडवलं तर आपल्याला मिळेल 6 मायनस 8.49 याला रूटच्या याने डिवाइड केलं तर 4.62 मायनस 3.3 3.00 like this. The summations is very sporty. We know Weber employ the mathematical conventions B by physical arrangement. Those the sodium ions at the phase center means functional functional atoms. The midpoint bear form a fractional fractional charge on corner bears plus or minus rho upon 8. Thus, contributions to lambda alpha alpha from unit cell is thus मग ह्या पद्धतीने त्यांनी ते परत केलं 1 6 into half by 1 12 into rho divided by 4 divided by rho 2 याच्या पद्धतीने हे समेशन सोडून घेतलं त्याचा पॉईंट इज इक्वल टू 1.46 अशा प्रकारे हे मॅथमॅटिकल डेरिवेशन्स आहे. सो this is a figure for selections of cubic face and this is a projection sign plane parallel to the cubic. Okay, so we have get the answer 1.46. Accurate answer sodium chloride 1.700 and 7475. So the total we add the contribution from imaginary large cube which has it is a faces containing the midpoint at the adjoining the cubes shown in a figure. आज इथपर्यंत बस झालं. आपण पुढचं लेक्चर घेऊ कोव्हॅलंट बॉन्ड.